minutes from now on. Okay? All right, that's better. All right, so how do we graph the square of x minus 2 minus 4 by transformation? No plotting point except you plot the fundamental functions. Well, right now, what do you see? This is a quadratic, okay? It's a quadratic function, and we would like to start with the fundamental function. So you would say start with y equal to x squared, right? Okay? How do you graph y equal to x squared? Can we graph quickly? Yes? All right. So let's plot some points, 0, 0. And what is next? 1, 1. And negative 1 also 1. How about 2? 2 will be 4. Okay? And then negative 2 also 4. Is that right? Yes. Okay. Now we have 5 points. It's better than 3 points now. If you have time, you can grab 2 more points. But now it's fine. Is that okay? Okay. Now, this is y equal to x squared. What should we do to get y equals to x minus 2 squared? You shift to where? To the right. So you write, shift it to the right 2 units. That is for us to obtain what? To obtain the graph of y equal to x minus 2 squared. Is that right? Okay. So you shift to the right. So this point will be shifted to here, right? All the points will shift to the right 2 units. So the origin is going to be here. This is my new origin. So as if this is the origin, you are going to have a parabola. Am I correct? Okay. So here, this is shifting to here. This is shifted to here. And this is shifted to here. And this is shifted to here. So I'm going to have the shifted. Is that right? This is y equal to x squared, but this is y equal to x minus 2 squared. Does it make sense to you? Okay. What's next? Well, after I get that, I still need to have, so look, what is this value? Tell me. Y value. So after I get this y value, I need to minus 4. So what is minus 4? Is the y value, is the y direction minus 4. So it is a shifting down. It's the y direction subtracting 4. Am I correct? So it is a vertical shift. Does it make sense? Yes? So step 3, shift it down 4 units to obtain the graph y equal to x minus 2 squared minus 4. So every point will shift down 4 points. 1, 2, 3, 4. Okay? So as if this is your new vertex. Okay? So you're going to have parabola passing this vertex. Okay, so everybody shift down 4 units. Does it make sense? So this was 1, was shift down to -3. Shift down. Shift down 3 units. 1, 2, 3. So up to here. 1, 2, 3. So up to here. One, 2, 3, 4, sorry. We shift down 4 units. Is that right? 1, 2, 3, 4. Okay, 1, 2, 3, 4. Shift down to here. 1, 2, 3, 4. Shift down to here. So I'm going to have this curve. So this is y equal to x minus 2 squared minus 4. Does it make sense to you? Is that okay? No? Okay. Which part? Can we do another one?
Yeah.
Yeah, we will.
Can I take a picture of that also for you?
Sure. If I had plus 4, then it will be shifted up 4 units.
What if the -2 was a +2, x minus 2?
Then you are going to shift to the left. Okay? We will do more. Yes? Can I make a what graph? Okay, can you read? You have to graph by transformation, no plotting points. The whole idea is, this is your Mickey Mouse, and I would like to make Mickey Mouse, jumping around. So in the imaging process, the movie industry are using a lot of this. And you have to know that linear algebra that if you are going to take is, this is a big thing. This is an area for making big money. I'm not kidding you. I have a very good friend at UCLA. Before he even graduated, he was hired by Hollywood and making big money. I mean, of course, it's not this fundamental, but this is for that. How do you make a Mickey Mouse jumping or, right now we are not stretching. When you smile, you have to massage the muscle, right? Then you are going to squeeze in and out. But now I'm just making the Mickey Mouse relocate. So if this is a Mickey Mouse and I want the Mickey Mouse to come down here, what I tell him to do is shift to the right and shift down. All this is done by computer. You don't need to redraw the whole Mickey Mouse. You just need to, have some kind of, yes?
So we plot the x squared
Yes.
by using 0, 1, 2.
Yes.
We shift it to the right 2.
Right.
Down 4.
Right. Very good.
What if on the paper we only have a spiral graph? Yeah.
Right now, you have to show me all the steps because this is your learning period, okay? After this class, 131, then, yes, you are so good. It's just like when you try to bike, you need a tricycle, right? Okay? And after you learn very well on tricycle, you can just go with bicycle, yes.
Because we wrote down everything we only just did one graph.
Oh, I see. For this time, it's okay. For this time, it's okay. Tomorrow, we will give you another quiz because Friday, you are going to have this. And you do need to have the mark indicating which graph corresponding to, transition for each step. Okay? Let's do one more. Now this time, you can tell me which function you would like me to graph. Okay? Let's look at your packet. Take your packet out. Okay, can we look at the page 16? All right. Which problem?
All of them.
I love you say all of them. That means you will know all of them. Okay, all right. We will start with the first one. How is that? Does it make sense? Okay, well, this is very simple because what do you see? X, sorry? Oh, it's page 16. Okay, so now you will write down step 1. You graph y equal to x squared. Okay, so let's graph it. So 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and you get this graph. Is it okay?
Yes.
Now, step 2. In order for you to get from x squared to, so now what do you get? You get y value, right? To x squared minus 4. It is after you get the y value, you subtract 4. So it's the y direction subtracting 4. Am I correct? So you shift what? You shift it down 4 units to get y equal to x squared minus 4. So 1, 2, 3, 4. The vertex will be shifted down to 0, negative 4. And this is like your new vertex, right? Or you can think about this as your new origin, and then you are going to have the parabola. Okay, so this is y equal to x squared minus 4. This is y equal to x squared. Does it make sense?
Yes.
So for all of these transformations, do you use y equals x squared to begin everything?
Yes, yes, that's our fundamental. The shape is not changed. It's just relocated. Is that okay? Okay, let's look at the second one. What to do with this second one? You will have step 1. You graph y equal to x squared, right? So again, you graph that. Okay? This is y equal to x squared. Now, after you get y equal to x squared, how do we get if within the parentheses we have x minus 2? Okay? So you know that this minus 2 is related to x. Two, you get 4. 2, because x squared, 2, you get 4, right? And negative 2, you also get 4. Because it's negative 2 times negative 2. Got it? Okay. Now, my x value is going to subtract 2, right? I got x squared already. If I want to get this, what should I do? I know what is this. It's here. Then how can I get that? Suggestion. Yes. shift to the right 2 units. Why? No memorizing. Because in order for you to get the same y value, I would like to have the same y value, right? The shape is not moving. My x, since it's going to subtract 2, my new x needs to be 2 more. So my new x is 2 more. So when I subtract 2, well, I will obtain the same y value. Okay?
So we don't give a number to x, let's say 1 minus 2, and then 2 minus 2, 3 minus 2. We don't give.
No, you don't. No. No table. No table. Okay? No table. Just say step 2, you just shift to the right 2 units. Then you will shift to the left. So shift to the left, to the right now for this problem. Do you have a red pen that I can borrow? Okay, now let me using red color so that we can differentiate. Oh, sorry, here. So this one is y equal to x minus 2 squared. Is that okay? Okay, now let's look at the last one. Now, this answers your question. Now you have first x plus 2 squared. So you start with y equal to x squared. All right? No doubt, everybody can do that. Step 2. In order to get x plus 2 squared, we need to shift to where? To the left. 2 units. So shift it to the left 2 units. What did you get? You get y equal to x plus 2 squared. So I shift to the left 2 units. Everybody shift to the left 2 units. Right? Everybody shift to the left 2 units. This one also shift. So this is y equals to x plus 2 squared. Is that okay? Now what do we do with this plus 1? Okay, remember, Remember, what is this value? This is what value? Y value. So if you are going to plus 1, is what direction plus 1? Y direction. Okay? Because I would like to have this plus 1 is Y plus 1. Is that okay? So step 3, I shift it up 1 unit to get y equals to x plus 2 squared plus 1. Is that okay? So I'm going to shift up. Now this time I'm going to use blue color. So everybody shift up. If you have color pen or pencil, make use of them. Okay? Can you see? Just everybody shift up. So the vertex will shift up. So let me ask you, where is the vertex? Tell me, where is the vertex? It will be -2, 1. Can you write it down on the side? Just write it down. You say vertex is -2, 1. Is that okay? Yeah. Yeah, I will ask you. Yeah. And now let me ask you, it is symmetric about this line. This is a vertical line, right? Is this a vertical line? Yes. So for that vertical line, how do you describe it? We call that is a line of symmetry. Okay? What is the line of symmetry? Where is the line of symmetry? It's this line. Do you see? This line is your line of symmetry. Yes? This line is your line of symmetry. Okay? How do you describe this line? It's passing x equal to -2. So this equation is what? X equals to -2. This vertical line, okay? Line of symmetry. Line of symmetry. Vertex. Does it make sense now? Yes. Oh, yes. Oh, yes. As I said to you, just like the previous test, what we test you is nothing but what was happening in class. Okay, it's very straightforward. I'm not asking you hard things. Okay? All right. Can I have you? Yes.
To do step by step, we need a label where the vertex
Yes.
is, the newly shifted vertex,
Yes.
and the line of symmetry.
Yes. Yes.
The line of symmetry is just
The vertical line that passing that vertex.
in the vertex. Got it.
Yes.
And then that's it.
That, well, yeah, I will tell you on the problem too. Is that okay?
Yes.
All right. Can we talk about this absolute value, my friend? Yeah. How about this one? We can just talk about it. What would you do? See? The shape would just like what? Absolute values, right? So you would start with what? Absolute value. What is the shape for absolute value? It's a V shape. Yeah? Okay. So let's do it. Okay. I will not rush, okay?
Bless you.
So what is the step 1? So page 17. Step 1. You will graph what? Y equal to absolute value of x. Am I correct? What is that? What is that? That is 0, you get 0, 1, 1, 2, 2, 3, 3, 4, 4, Did you see that? And negative 1, you get 1, 2. Negative 2, you get 2, 2. Right? This is your y equal to absolute value of x. Okay? Does it make sense? Is this the absolute value function? Yes. Okay? Now what's next? We would like to get absolute value of x minus 6. Because x is going to subtract 6. So my new value, in order for me to get the same y value, my new x value needs to be 6 more, right? Because your x is going to take away 6. So my new x value needs to be 6 more. What do you mean x need to be 6 more? This is positive. Means what? You shift to the right 6 units. Okay? So step 2, shift it to the right 6 units to get y equals to absolute value of x minus 6. Right? Does it make sense? If you feel it makes sense, raise your hand. Yeah? Okay. If you don't, now raise your hand.
Well, I'm not sure why x equals absolute value. I know y equals absolute value of x. Like, why is that shape?
Oh, the shape is not this. I need to shift to the right. So I kind of moving the whole V shape to the right 6 units.
I'm just saying, why is it like that opposed to the parabola or whatever?
Oh, you mean why the shape for absolute value is that?
Yeah.
Got you. That is the fundamental function. You need to know how you find the absolute value of x. When x equal to 0, it is what? 0. So 0, 0, right? When x equal to 1, it is what? 1. Absolute value of 1 is 1.
Yeah.
When x equal to 2, it is what? 2. When x equal to 3, it is 3. Right? How about when x equal to negative 1? Absolute value of negative 1 is 1. Absolute value of negative 2 is 2. So it is the other side.
Okay.
You would like to plot it so that it makes, it's visible. So try to make the graph reasonable. If you only plot these 3 points, it's going to be so tiny. And, well, since it's straight line, why don't you just make it longer? Okay? All right. Now, how do you continue and finish it? You are going to have, now, y equals to x minus 6 with the absolute value. Now, you would like to go from here and then plus 2. So you get the y value, and you are going to plus 2. So who is plusing 2? Y or x? Y, right? It's the y direction plus 2. Does it make sense? After you get the y value, this is your y value, and then you plus 2. So y direction plus 2. Is that okay? So what do you shift to? You shift what? Shift it up. How many units? 2 units.
You won't have to graph the second one?
I need to. I will do it after I finish it. I am giving instructions to a robot. Okay, I'm not going to graph it. I'm going to tell the robot, you just move it for me. Okay? You are moving the graph, right? You are moving the whole graph to the right 6 units. So the robot say, okay, yes, sir. I'm going to move it. Okay, so it's moving 6 units. Right? And then this part also moving 6 units. So you are having the same shape. Basically, you are having the same shape. So you know what? Smart people would say, because it's the same shape as the original graph, I only need to find out where's the vertex or where is the critical point. Then I can draw it. Am I correct? All right, so now you have to shift it up 2 units. So I shift up. So this is y equal to absolute value of x minus 6. Okay, and now shift it up. Is that okay? I shift to the right 6 units, and then I shift up. Is that okay? Yeah.
Do we draw line of symmetry or?
Not for this one. You may if people ask you, but then most of the time people care about the line of symmetry for parabola. Yeah. Yeah, you do have symmetry for absolute value function too. Yeah.
Can we write the vertex?
If we asked you. Yeah. Yeah, you of course you can write out where's the vertex. The vertex will be 6, 2. Okay? Thank you so much. And then now I think that with that I want you to look at page 20. I think page 18 and page 19 you just need to do it similarly, right? Okay. Did you finish up to page 19? No. Okay. All right. Okay. If you, great job. Yes.
For our exam on Friday, I think there was a study guide, so you know exactly what's on it.
Yes. It will be just like what we do in class. All these problems will show up on your, all similar. Okay. Let's look at page 18 and 19. It's just different function, but the steps. Say it again.
Can we have like a cheat sheet for Friday? Like
Cheat sheet?
formulas on it?
Cheat sheet? Formula. What formula?
There's a lot of stuff to remember. Whatever we need to remember, can we put it on a little card?
Huh. Why don't you do this? Why don't you have a cheat sheet? Let me look at your cheat sheet tomorrow and decide which part worth you to put on the cheat sheet. Okay? I don't think so. In the past, there's no cheat sheet allowed for any exam. But you can tell me and I can take a look. I'm not kidding you. Yes, I do want to consider. But I have to tell you, those fundamental functions, you should dream about them. Okay? All right. And we call them parent function. Look, they are like your parent, right? You will never forget about your parent. Am I correct? Okay, page 20. Okay, so let's very quickly go through them. And if you are going to say cheat sheet, then this sheet will be your cheat sheet.
Not cheat sheet, okay, help guide, whatever you want to call it. Something where it can
Okay,
guide us for the test.
all right. So provide it to me tomorrow. And then I will try to emphasize in class enough so that you don't need that.
Because there are some things like when I'm going through the chapter, like I'll forget exactly how to do it.
Mm-hmm.
I can refer to that to get an idea.
Then I will try to help you to remember how to do it before you have the test. Because you will not be allowed to take any cheat sheet for any exam. Yeah, for sure. Yeah, so sorry. Yeah?
No problem. So you will be giving us a study guide to see these are the equations you need to learn for sure, because these are the ones that will be on the
Tonight you will have a packet that you can download it and print it out, and you get extra point if you bring it back tomorrow or the day after tomorrow. So I do give you some kind of practice. Yes. Yeah.
So that the packet's going to be online.
Yeah, it will be online.
That's like the study
And-
guide for the test.
No, I will not say that. But those are the problems like what we are doing in class. But maybe you would like to see it. Okay. All right. So those are the parent functions that we provided here. Can I have you look at page 21? Okay. It is just for you to quickly. So for example, there are 1, 2, 3, 4, 5, 6, 7 function notations, and we want you to tell us, look at the graph, can you name them? Okay? You must be trained so that you can know them by heart. Okay? All right. So page 22, okay, let's look. Oh, you know what? Can I have you look at the page 21 and let's see, can you match them? And then you would, we just talk about it, but we don't write on it so that, you know, you will reconsider that when you get home. Which one corresponding to the function L? Y equals to x. Which graph corresponds to y equals to x? Great job. Okay, which graph corresponds with y equal to x squared? 1. Oh, very good. Yes. She just showed me that we actually already gone over that in class. Yes, we did. Yeah. And you should keep them in mind. Yes, thank you. That's wonderful. Yes, we did. Okay, can I ask you which one corresponds with the function c? Which one? 6. Right? That is x cubed. It's all on your notes last Friday, okay? All right, thank you. And today we are going to continue with the function g. Okay, like absolute value a, it's the number 3, right? How about the square root? S. 2. Wonderful. How about f? Cube root? No, 6 is cube. 7 is a cube root. Okay. Now the last one is today's. We are going to learn. Okay, g of x, 2 to the power x. 2 to the power x. This is one of the fundamental function, and we are going to learn it today. And I'm going to pass you the packet. Okay? We will cover the first 3 sections. The section 4 and 5, you would just keep them for later. Okay, so up to section 3 will be covered this week. All right. First of all, I want all of you have a graph paper. Can I have all of you have a graph paper up again? Graph paper? A piece of graph paper. Oh, you run out. Oh, you give to other people. All right, that's okay. That's okay. Sorry? I think some of them. I would like you. Yeah. Okay. Don't worry. Okay. Just have a. We're going to have a notes. Okay. All right. Just take notes. We are going to start our new section 8.1. Okay. Open your book to 8.1. And I want to tell you, chapter 8 is a very, very important chapter. Last Friday, we talked about how to graph the sum, the difference of 2 functions, right? And we can add, subtract, multiply, and divide functions. Now today we are going to introduce a new operator of functions. Can you see it? Yes? Composition functions and inverse functions. I will try my best to make this as straightforward as possible to all of you. Okay. So let's start with definition. And you will be tested tomorrow for one of the quiz problems. Yes. Remember that I test you what is a definition for a function? And right now you need to learn what do you mean by composition function. Okay? So given two functions, f and g, okay, with domain d sub f and d sub g. Okay? D is a domain. That means that is a domain for f. That is a domain for g. The composite function denoted by f circle g. People do read it sometimes, f circle g, but then you should read it for most of the time as f composed with g. Okay? Is defined by the following. Okay? Now, let's read out loud. How do you say this symbol? F composed with G, right? F composed with G of X is F of G of X. Can I have you all say out loud? 5 times. Yes, 5 times. Okay, 1, 2, 3. F composed with G of X is F of G of X. F composed with G of X is F of G of X. F composed with G of X is F of G of X.
F composed with G of X is F of G of X. F composed of G of X is F of G of X.
Ah. You have to say one more time. Loudly, okay? F composed with G of X is F of G of X. Well, this is how you say it. A lot of people, they don't know how to say it, and then they just freak out, okay? This is a new operation among functions, okay? So what does it say here? It's just like machine. Remember, a function is like a machine, okay? So if this is a function f, you have input x. So tell me, what is the output? F of x. Is that right? And for g, you could have a machine g. If the input is a, then the output will be what? G of a. Is that right? Okay. Now, what we say here is, given x, okay, x is the input, right? Is x input?
Yes.
Now I have 2 machines. One machine is f, the other machine is g. Look at this. Be creative, okay? It's very straightforward. Now x is going to go in one machine. Can you tell me which machine it goes in first? Look at it, look at it. I say this is a new machine. Okay, that means what? Oh, that means something. We learned this, right? This is something new we are going to learn. But we learned this. So give me an x. What machine x will go into first? Thank you. This is your inner function. Okay? You would go into G first. So actually, give me an input. I go into G first. So can you tell me what is the output? G of x. Thank you. Thank you. What's your name? Albert. Get extra point. Okay. Now you get G of x. All right. Now what do you see? G of x will become the input for what function? F. Thank you. So now this is the input for G, right? Now after you get G of x, it's going to become the input for F. Are you with me? So, no? Oh, okay. You don't know what is G and F. Okay. Just like a machine. Okay. It's like an assembly line. You have something that you would like to process first, right? When we wrap gift, we would try to put the tissue paper first, right? And then we'll put into a box, right? So the wrapping paper will be done first. The second step will be putting into the box. The last will be ribbon. Am I correct? So the input is like a gift, okay? The G is like the wrapping. And then after you wrap, you put into a box. Okay, you put into a box, and what do you get? Remember, G of x is already wrapped gift. G is like you make it a gift wrapping, okay? And then that will put into a foil box, okay? So this is going to be F, right? It's become F of G of x because G is the input. G of x is the input. Let's do some example. Okay? All right. Let f of x equals to x squared. Let g of x equals to 2x plus 1. Okay. Now, I want to find f composed with g. Okay, so now everybody be patient. Tell me, how do I define f composed with g of x? Is what? F of g of x. Thank you. If you write this down, you get 2 points. And then next, what do you do first? Tell me, my friend. What function you will go in first? G, right? G, right? This is your inner function, right? Okay? So what do you do with f? Copy down. So copy, you know how to copy it down? I copy it down. So what is g of x? Tell me. 2x plus 1. So I put 2x plus 1 here. I try to bold it to make sure that you know this is the current action. Okay? I am only doing the inner function, g of x. All right. So 2x plus 1. Now I am going to have 2x plus 1 as a whole packet and throw it into the machine f. This is my input. I don't know what is this number, right? I mean, I don't care. This could be a beautiful flower. It could be a diamond. I don't know, right? But I am going to put this into f. Oh, look at what f would do for you. it's going to square. So if you have a diamond, it's become diamond square. Okay? So, I love that idea. So F is a function or a machine can take whatever input and square it. Does it make sense? All right. So what is the input right now? 2x plus 1. So I am going to, this is the whole thing, I'm going to square whatever you give me. So I'm going to have 2x plus 1, the whole thing square. Does it make sense? Does it make sense to you? Oh, what is a square? Oh, okay, come back. Go back, go back. If I have f of 3, then I would have what? 3 square, right? If here is 5, then going to f, it will be 5 square, right? Yes? If here is 10, then going to f, what do you have? 10 square, right? But now I don't have a number. I have 2x plus 1. I look at it as a whole, okay? The whole thing is going to be squared. Does it make sense? The whole thing here, I blurred it, okay? The whole thing, whatever that here is going to become the input for the machine F. And I'm going to have the whole thing. Now what is the whole thing? 2x plus 1 squared. Is that okay? Yes. All right, can you tell me what is that? It is 2x plus 1 times 2x plus 1. So you will get 4x. You can distribute it, can't you? Plus 2x plus 2x plus 1. So you get 4x squared plus 4x plus 1. Does it make sense? Okay? Part B. You find G composed with f of x. Okay, so what is that? That is G of f of x. Right? Yes or no? What is G composed with f of x? Is G of f of x, right? Okay, so what is the inner function? Can you tell me? G or f? Which one is the inner function? F. Okay, so I would start with f. What is f? X squared, right? X squared. Am I correct? Okay, so now I say, hey, x squared. Now this is my input for what machine? For G. But what is G? What is G? G is 2 times the input plus 1. So this is the input. G is 2 times input plus 1. Now the input is x squared, right? So it's 2 times input plus 1. Is that okay? So what is the result? It's 2 times x squared plus 1. Is that okay? Yes or no? Now you compare. What? What do you mean x? No, this is your input. This is your input. Okay, this is your input. G of whatever is 2 times whatever plus 1. Okay? Is that okay? All right, look. This is G of, say here is A. Then you will have 2A plus 1. If this is B, you will have 2B plus 1. If this is 5, it's 2 times 5 plus 1, right? Whatever input, you just put the input here. Right now, the input is what? Right now, the input is x squared, right? So you have 2 times x squared plus 1. Are they the same? Are they the same? Not the same. So f composed with G is not G composed with f. Okay? Today's homework will be 8.1, all related things. I take away, okay, we have to go. I take away the quizzes. You don't need to do quizzes on My Math Lab anymore. Is that good news? Okay, let's go. Let's go. We have to go. We have to go.